Isaac Newton. Isaac Newton is perhaps the greatest physicist who has ever lived. He and Albert Einstein are almost equally matched contenders for this title. Each of these great scientists produced dramatic and startling transformations in the physical laws we believe our universe obeys, changing the way we understand and relate to the world around us. Isaac Newton was born on January 4, 1643 in the tiny village of Worcester by Costleworth, Lincolnshire, England. His father, whose name was also Isaac Newton, was a farmer who died before Isaac Jr. was born. Although comfortable financially, his father could not read or write. His mother, Hannah Iskoff, married a churchman when Newton was 3 years old. Newton disliked his mother's new husband and did not join their household, living instead with his mother's mother, Marguerite Iskoff. His resentment of his mother and stepfather's new life did not subside with time. As a teenager, he threatened to burn their house down. Beginning at age 12, Newton attended the King's School, Grantham, where he was taught the classics, but no science nor mathematics. When he was 17, his mother stopped his schooling so that he could become a farmer. Fortunately for the future of science, Newton found he had neither aptitude nor liking for farming. His mother allowed him to return to school, where he finished as top student. In June 1661, aged 18, Newton began studying for a law degree at Cambridge University's Trinity College, earning money as a personal servant to wealthier students. By the time he was a third-year student, he was spending much of his time studying mathematics and natural philosophy. Today, we call it physics. He was also fascinated by alchemy, which is now categorized as a pseudoscience. His natural philosophy lectures based their courses on Aristotle's incorrect ideas from ancient Greek times. This was despite the fact that 25 years earlier, in 1638, Galileo Galilei had established a new scientific basis for the physics of motion with his masterpiece, Two New Sciences. Newton began to disregard the material taught at this college, preferring to study the recent and most scientifically correct works of Galileo Galilei, Boyle, Descartes, and Kepler. Reading the works of these great scientists, Newton grew more ambitious about making his own discoveries. While still working part-time as a servant, he wrote a note to himself. In it, he posed questions not yet been answered by science. These included questions about gravity and nature of light, the nature of color and vision and atoms. After 3 years at Cambridge, he won a 4-year scholarship. This allowed him to give up working as a servant and devote his time fully to academic studies. In 1665, at age 22, a year after beginning his 4-year scholarship, Newton made his first major discovery. This was in mathematics, where he discovered the generalized binomial theorem. He was awarded his Bachelor of Arts degree in the same year. By now, his mind was ablaze with new ideas. He began making significant progress in 3 distinct fields. He would make some of his most profound discoveries in these fields: calculus, the mathematics of change, which is vital to our understanding of the world around us, gravity, optics, and the behavior of light. He did much of his work on these topics back home at Worcester by Costleworth after the Great Plague forced Cambridge colleges to close. At age 24 in 1667, Newton returned to Cambridge, where events moved quickly. First, he was elected as a Fellow of Trinity College. A year later, in 1668, he was awarded a Master of Arts degree. A year after that, a Lucasian professor of mathematics at Trinity College, Isaac Barrow, resigned and Newton was appointed as his replacement. He was just 26 years old. Isaac Newton, who was largely self-taught in mathematics and physics, generalized the binomial theorem, showed that sunlight is made up of all the colors of the rainbow. He used one glass prism to split a beam of sunlight into its separate colors, then another prism to recombine the rainbow colors to make a beam of white light again. Built the world's first working reflecting telescope, discovered and invented calculus, the mathematics of change, without which we could not understand the behavior of objects as tiny as electrons or as large as galaxies. Isaac Newton wrote the Principia, one of the most important scientific books ever written. In it, he used mathematics to explain gravity and motion. Isaac Newton discovered the law of universal gravitation, proving that the force holding the moon in orbit around the Earth is the same force that causes an apple to fall from a tree. Isaac Newton formulated his 3 laws of motion, Newton laws, which lie at the heart of the science of movement. Isaac Newton showed that Kepler's law of planetary motion are special cases of Newton's universal gravitation. He also proved that all objects moving through space under the influence of gravity must follow a path shaped in the form of one of the conic sections, such as circle, an ellipse, or a parabola, hence explaining the paths all planets and comets follow. He also showed that the tides are caused by gravitational interactions between the Earth, the Moon, and the Sun. He predicted correctly that the Earth is not perfectly spherical, but is crashed into an oblate spheroid larger around the equator than around the poles. He used mathematics to model the movement of fluids, from which the concept of a Newtonian fluid comes. He devised Newton's method of finding the roots of mathematical functions. Newton revealed his laws of motion and gravitation in his book The Principia. Just as few people at first could understand Albert Einstein's general theory of relativity, few people understood the Principia. When Newton walked past them one day, one student remarked to another, "There goes a man who has written a book that neither he nor anyone else understands." Newton's ideas were spread by the small number of people who understood the Principia and who were able to develop and convey its message in more accessible ways. Newton was the first person to fully develop calculus. Calculus is the mathematics of change. Modern physics and physical chemistry would be impossible without it. Other academic disciplines, such as economics, also rely heavily on calculus for analysis. In his development of calculus, Newton was influenced by Pierre de Fermat, who had shown specific examples in which calculus-like methods could be used. Newton was able to build on Fermat's work and generalized calculus. From Newton's fertile mind came the ideas that we now call differential calculus, integral calculus, and differential equations. Soon after Newton generalized calculus, Gottfried Leibniz achieved the same result. Today, most mathematicians give equal credit to Newton and Leibniz for calculus discovery. Newton's famous apple, which he saw falling from a tree in the garden of his family home in Woolsthorpe by Castleworth, is not a myth. He told people that seeing the apples fall made him wonder why it fell in a straight line towards the center of our planet rather than moving upwards or sideways. Ultimately, he realized and proved that the force behind the apple's fall also causes the moon to orbit the Earth, and comets, the Earth, and other planets to orbit the sun. The force is felt throughout the universe, so Newton called it universal gravitation. In a nutshell, it says that mass attracts mass. Newton discovered the equation that allows us to calculate the force of gravity between two objects. Most people don't like equations much. Capital letter E equals mc2. It's as much as they can stand. But for the record, here is Newton's equation. Newton's equation says that you can calculate the gravitational force attracting one object to another by multiplying the masses of the two objects by the gravitational constants and dividing by the square of the distance between the objects' centers. Dividing by distance squared means Newton's law is an inverse square law. Newton proved mathematically that any object moving in space affected by an inverse square law will follow a path in the shape of one of the conic sections, the shape which fascinated Archimedes and other ancient Greek mathematicians. For example, planets follow elliptical paths, while comets follow elliptical or parabolic or hyperbolic paths. And that is, Newton showed everyone how, if they wished to, they could calculate the force of gravity between things such as people, planets, stars, and apples. Newton's laws of motion. Third law. The object flies because of the upward thrust it gets as a reaction to the high-speed gas particles pushing downward from its engines. Newton's third laws of motion still lie at the heart of mechanics. First law. Objects remain stationary or move at a constant velocity unless acted upon by an external force. This law was actually first stated by Galileo, whose influence Newton mentions several times in the Principia. Second law. The force F on an object is equal to its mass m multiplied by its acceleration, which is F equals ma. Third law. When an object exerts a force on the second object exerts a force equal in size and opposite in reaction on the first object. With Newton's calculus, universal gravitation, and laws of motion, you have enough knowledge at your fingertips to plot a course for a spaceship to any planet in your solar system or even another solar system. And Isaac Newton figured it all out about 300 years before we actually did send a spaceship to the planets. Newton was not just clever with his mind, he was also skilled in experimental methods and working with equipment. He built the world's first reflecting telescope. This telescope focuses light from a curved mirror. Reflecting telescopes have several advantages over earlier telescopes, including they are cheaper to make, they are easier to make in large sizes, gathering more light, allowing higher magnification. They do not suffer from a focusing issue associated with lenses called chromatic aberration. Newton also used glass prism to establish that white light is not a simple phenomenon. He proved that it is made up of all the colors of the rainbow, which could combine to form white light again. Although he is not one of the greatest scientists in history, Newton's laboratory papers showed he probably devoted more of his time to alchemy than to anything we could recognize as science. Not surprisingly, Newton never found the philosopher's stone. Given his towering contributions to real science, all we can do is wonder what else he might have achieved if he had not been such a passionate alchemist. Despite his brilliance, Newton was a very insecure man. Most historians trace this back to his childhood family difficulties. Newton published very little work until his later years, because in his early years as a scientist, Robert Hooke disagreed strongly with the scientific paper Newton published. Newton took criticism of his work in a very personal way and developed a lifelong dislike for Hooke. His lack of published work also caused a huge issue when Gottfried Leibniz started publishing his own version of calculus. Newton was already a master of this branch of mathematics, but had published very little of it. Again, Newton's insecurity got the better of him, and he angrily accused Leibniz of stealing his work. The pros and cons of each man's case have long been debated by historians. Most mathematicians regard Newton and Leibniz as equally responsible for the development of calculus. Newton was a very religious man with somewhat unorthodox Protestant Christian views. He spent a great deal of time and wrote a large body of private works concerned with theology and his interpretations of the Bible. His scientific work had revealed a universe that obeyed logical mathematical laws. He had also discovered that starlight and sunlight are the same, and he speculated that stars could have their own systems of planets orbiting them. He believed such a system could only have been made by God. This most beautiful system of the sun, planets, and comets could only proceed from the counsel and dominion of an intelligent and powerful being. And if the fixed stars are the centers of others like the systems, these, being formed by the like wise counsel, must be all subject to the dominion of one, since the light of the fixed stars is of the same nature with the light of the sun. In 1696, Newton was appointed as a warden of the Royal Mint. In 1700, he became master of the Mint, leaving Cambridge for London and more or less ending his scientific discovery work. He took his new role very seriously, going out into London's taverns and disguised gathering evidence against counterfeiters. In 1703, he was elected president of the Royal Society. In 1705, he was knighted, becoming Sir Isaac Newton. Isaac Newton died on March 31st, 1727, aged 84. He had never married and had no children. He was buried in Westminster Abbey, London.